Hey everyone, welcome back. In our last video, we explored what Java is and its incredible journey from 1991 to today. But now comes the really important question. Why is Java so popular? What makes it special compared to hundreds of other programming languages out there? Today, we're diving deep into the features and advantages that make Java an absolute powerhouse in the programming world. And trust me, by the end of this video, you'll understand exactly why companies like Google, Amazon, Netflix, and even NASA choose Java for their most critical systems. So let's jump right in. All right, think about this for a second. Imagine you're buying a car. You wouldn't just pick any random car, right? You'd want one that's reliable, safe, fuel efficient, easy to maintain, and works well in all kinds of weather. That's exactly how developers think when choosing a programming language. And Java? Java is like that perfect all-weather reliable car that just keeps going. Let me start with the first major feature. Java is simple and easy to learn. Now you might be thinking, wait, I've heard programming is super hard. And yes, some languages are hard. But Java was specifically designed to be easier than its predecessors, especially C and C++. Think of it this way. C++ is like flying a commercial airplane. Incredibly powerful, but with hundreds of buttons and controls that take years to master. Java is like flying a modern, user-friendly drone, still powerful, but much easier to understand and control. Java removed all the confusing, error-prone features from C++. No pointers causing memory crashes, no operator overloading making the same symbol do 10 different things, no multiple inheritance creating complicated family trees of code. Java said, let's keep it clean and simple. Here's a perfect example. In C++, you have to manually manage memory, allocate it, use it, and remember to free it up. Forget that last step, your program crashes or leaks memory like a broken faucet. But in Java, Java handles all of that automatically. You just use your objects, and Java cleans up the mess for you. Now let's talk about what makes Java truly revolutionary. Platform independence. This is the famous write once, run anywhere philosophy, and it's absolutely game-changing. Imagine you write a book in English. Normally, you'd need to translate it into Spanish for Spanish readers, French for French readers, Chinese for Chinese readers. You get the idea. But what if you had a magical book that could automatically appear in whatever language the reader needed? That's exactly what Java does for computers. Here's how it works. When you write Java code, the Java compiler doesn't convert it directly into Windows-specific or Mac-specific instructions. Instead, it creates something called bytecode. Think of it as a universal intermediate language. Then, the JVM, the Java Virtual Machine, on any computer, Windows, Mac, Linux, Android, can read this bytecode and run it perfectly. This means you write your code once, and boom, it runs on your Windows laptop, your friend's MacBook, your company's Linux servers, your Android phone, even your smart TV. No changes needed. Can you imagine how much time and money this saves companies? Instead of maintaining separate code bases for different platforms, they write it once. Revolutionary. The third major feature is that Java is object-oriented. Now, what does that mean? Everything in Java is organized around objects. Think of them as real-world things with properties and behaviors. Let me give you a simple analogy. Instead of writing code as one long list of instructions, like a never-ending recipe, object-oriented programming lets you organize code like Lego blocks. Each block is self-contained and can be reused in different projects. Think about a car in the real world. It has properties, color, brand, model, current speed, and it has behaviors, start, stop, accelerate, brake. In Java, you'd create a car object with all these properties and behaviors bundled together in one neat package. This approach has four main pillars. First, encapsulation, bundling data and methods together while hiding internal details, like a TV remote. You press buttons without knowing about the complex circuitry inside. Second, inheritance, creating new classes based on existing ones. A sports car inherits all the properties of a regular car, but adds special features like turbo boost. Third, polymorphism. Same action, different behaviors. The draw command draws a circle differently than it draws a square. And fourth, Abstraction, showing only essential details. Your car's steering wheel is simple to use, but it hides incredibly complex mechanics beneath. Why does all this matter? Code reusability. Write once, use many times. Easy maintenance. Fix bugs in one place, not scattered across thousands of lines. Scalability. Add new features without breaking existing code. And team collaboration. Different developers can work on different objects simultaneously. Now, let's talk about robustness. Java is robust and reliable. What does that mean? Java programs are stable, they don't crash easily, and they handle errors gracefully. Imagine two bridges, one made of wood that might break under heavy load, and one made of reinforced steel that's been tested for every possible condition. Java is that steel bridge, built to handle problems without collapsing. Java achieves this through strong type checking. Java checks your data types before your program even runs, catching errors early before they become disasters. If you try to store text in a number variable, Java immediately says, "Hey, that doesn't make sense." Problem solved before it causes a crash. Then there's automatic memory management, also called garbage collection. In C++, if you forget to clean up memory, you get memory leaks. Your program slowly eats up all available memory until everything crashes. Java automatically finds and removes unused objects, like having a cleaning crew that works in the background while you focus on important stuff. Java also has exception handling. This forces you to handle potential errors. Instead of your program just crashing when something goes wrong, Java lets you catch the error and deal with it gracefully. Division by zero, no problem. Java catches it, shows a nice error message, and keeps running. Pointers in C and C++ are notorious for causing crashes and security vulnerabilities. Java eliminated them entirely. Result? Fewer bugs, more stability, happier developers. This is why banks trust Java with your money, why hospitals use Java for critical medical systems, why air traffic control systems, where crashes are absolutely not an option, rely on Java. Security. Java is incredibly secure, and this is huge. Java has multiple layers of built-in security, protecting against viruses, hackers, and malicious code. Think of Java as a fortress with multiple layers of defense. Guards at every gate, security cameras everywhere, strict rules about who can enter which areas. That's Java's security model. First, no pointers means hackers can't manipulate memory directly. They can't access restricted areas of your computer. Second, bytecode verification. Before running any code, Java checks if it's safe, like airport security scanning every piece of luggage before it gets on the plane. Third, the security manager controls what Java programs can and cannot do. A Java app you downloaded can't just delete all your files without permission. Fourth, the class loader separates local trusted code from internet downloaded code and treats them very differently for safety. And fifth, sandboxing. Java applets run in an isolated sandbox environment. Even if they're malicious, they can't harm your actual system. It's like letting a potentially dangerous animal play in a secure cage. It can't hurt anyone. This is why your online banking uses Java, why government systems handling classified information use Java, why any system dealing with sensitive data trusts Java. Now multithreading. Java can do multiple things at the same time, and this is incredibly powerful. Think about what you're doing right now. Maybe you're watching this video while a file downloads in the background, while music plays, while your antivirus scans your system, all happening simultaneously. That's multithreading. In single-threaded programs, tasks happen one after another. Do task 1, wait for it to finish, then do task 2, wait, then task 3. If each task takes 10 seconds, you wait 40 seconds total. But with multithreading, all 4 tasks run at the same time. Total time, just 10 seconds. You've just saved 30 seconds. This is crucial for video games, rendering graphics while processing player input while playing sound effects. For web servers handling thousands of user requests simultaneously. For video streaming platforms, downloading the next part of the video while playing the current part. For chat applications, sending your messages while receiving new ones. Modern Java is also high performance. Now, early Java in the 1990s, honestly, it was pretty slow. But modern Java, it's blazingly fast, competing with C++ in many scenarios. As your program runs, the JIT compiler identifies frequently used code and compiles it into native machine code for maximum speed. It's like having a smart assistant that learns what you do most often and optimizes those tasks. Let me put this in perspective. C++ runs at about 100% speed because it compiles directly to machine code. Modern Java with JIT, about 92%, almost identical. Python, which is interpreted, only about 35%. Huge difference. This is why Twitter handles 500 million tweets per day using Java, why LinkedIn serves over 900 million users with a Java backend, why Netflix streams to 230 million subscribers using Java microservices. These are massive scale operations, and Java handles them beautifully. Java is also excellent for distributed computing. What does that mean? Java makes it easy to build applications that work across multiple computers and networks. Imagine a company with offices in New York, London, and Tokyo. Java allows all three offices to work on the same project seamlessly, sharing data and resources as if they were in the same room. Java has built-in networking support, making communication between computers incredibly easy. This is perfect for cloud computing, microservices architecture, content delivery networks, and multiplayer online games where players around the world interact in real time. And finally, Java is dynamic and extensible. Java programs can adapt and grow without needing complete rewrites. Think of Java like Lego. You can add new pieces, replace old ones, or rearrange them without destroying your entire creation. Java supports dynamic class loading, meaning you can load new features while your program is running. No restart needed. It has reflection, where programs can examine and modify themselves at runtime, and it easily integrates with other languages when needed. Now let's compare Java with other popular languages real quick. Java versus Python. Java is faster, perfect for Android apps, and industry standard for enterprise. Python is easier to learn and better for data science. Both are great, just for different purposes. Java versus C++. Java has automatic memory management, no manual cleanup needed, no confusing pointers, platform independent. But C++ is slightly faster for system-level programming. Java wins for business applications and Android. Java versus JavaScript. Despite the similar names, they're completely different languages. Java is for back-end systems and Android. JavaScript is for web front-end. The similar names? Just a marketing decision from 1995. Now, where does Java dominate in the real world? Number 1. Android development. 90% of Android apps are built with Java. 3 billion Android devices worldwide run Java code. Apps you use every day, WhatsApp, Spotify, Twitter's original version, all Java. Number 2. Enterprise applications. Google, Amazon, Netflix, LinkedIn, Uber, Airbnb all use Java extensively. Why? It scales to handle millions of users. It's reliable with 99.99% uptime. It's secure for critical financial data. Number 3. Banking and finance. JP Morgan Chase, Goldman Sachs, Citibank, American Express all use Java. Online banking, trading platforms, payment processing, all Java. When your money is on the line, security and reliability are non-negotiable. Number 4. Web applications. LinkedIn.com, parts of Amazon, eBay, Alibaba, all powered by Java on the back end. Number 5. Scientific applications. MATLAB uses Java for its interface. NASA uses Java for space mission software. CERN analyzes particle physics data with Java. Weather forecasting systems run complex simulations on Java. Number 6. Big data. Apache Hadoop, Apache Spark, Apache Kafka, Elasticsearch, all Java-based. Twitter analyzes billions of tweets. Netflix recommends shows you'll love. Uber matches riders with drivers, all powered by Java big data tools. Number 7. Gaming. The original Minecraft was built entirely in Java. RuneScape, countless mobile games, Java-powered. And number 8. Internet of Things. Smart home devices, wearable technology, industrial sensors, automotive systems. Java runs on small devices everywhere. Let me give you some incredible statistics. Over 9 million Java developers worldwide. 1.5 million GitHub repositories. 40,000 active job postings in the USA alone. 3 billion Android devices. 90% of Fortune 500 companies use Java. It's been in the top 3 programming languages for over 20 years. Average salary for Java developers in the USA? $95,000 plus. Now, let's bust some common myths. Myth 1. Java is slow. Busted. Modern Java with JIT compilation is extremely fast. Myth 2. Java is dying. Busted. Java consistently ranks in the top 3 and is still growing. Myth 3. Java is only for old enterprise apps. Busted. Used in cutting-edge AI, big data, cloud, and microservices. Myth 4. Java is too hard for beginners. Busted. It's easier than C++, has excellent resources, and makes a great first language. Myth 5. Java and JavaScript are related. Busted. Completely different languages that only share similar names. Now, to be fair, Java isn't perfect for everything. Avoid Java for system-level programming. Use C++ or Rust instead. For data science and machine learning, Python is better. For front-end web development, use JavaScript. For quick automation scripts, Python is faster. For iOS apps, you need Swift. But for Android, enterprise systems, large-scale web applications, big data, and e-commerce, Java dominates. Let's summarize the key takeaways. Java is simple with clean syntax. Platform independent, write once, run anywhere. Object-oriented for organized, reusable code. Robust and reliable with excellent error handling. Secure with built-in protection. Multi-threaded for concurrent operations. High performance thanks to JIT compilation. Distributed for network applications. And dynamic for easy extensibility. Java powers 3 billion Android devices, used by 90% of Fortune 500 companies. 9 million developers worldwide. Perfect balance of power and simplicity. Excellent job prospects and salary. 30 years of continuous evolution. And a massive helpful community. Your Android phone runs Java. Your online banking uses Java. Netflix uses Java. LinkedIn, Amazon, and Google rely on Java every single day. So there you have it. Now you understand not just what Java is, but why it's so powerful and widely used. In our next video, we're going to explore the different editions of Java. Java SE, Java EE, Java ME, and Java FX, and figure out which one you should learn. This is super important because choosing the right edition can save you tons of time. If you found this helpful, please smash that like button. It really helps the channel. Subscribe if you haven't already, and hit that notification bell so you don't miss the next video. Drop your questions or comments below. I read every single one, and I'm here to help you succeed. Thanks so much for watching, and I'll see you in the next one where we break down Java editions. Until then, happy learning.